So Yasser, you can present when you're ready.
Thank you, David, and good morning, everybody. Happy Thursday. So today I'm going to be sharing my screen here, and we're going to be presenting, John and I, on AWS's DevOps tools for continuous integration, continuous deployment development. These tools mainly comprise of code commit, code build, and code pipeline. There are a couple others. There's code deploy, but we're not going to get into that today. And the main reason is because we leverage CloudFormation template for the demonstration today, and so forth. So we're going to dive into those three AWS managed services. I'll kick it off, and then John will step in on some other slides. So can everyone see the screen okay, or do you guys want me to go into presentation mode style?
I can read it okay.
Okay. All right. So the agenda, we're going to start with giving you an overview of code commit, and then code build, and then code pipeline. And then we're going to bring it all together into a use case. It's a real use case that we've developed and we modeled. It's deployment, the Alfresco stack, leveraging ECS Fargate. We talked about ECS Fargate in our last workshop, but this is the AWS managed service for container orchestration, leveraging a serverless framework. All right, let's start with talking about code commit. So code commit is a managed service, fully managed service provided by AWS. You don't have to worry about giving it a server. You don't have to worry about its sizing and its requirements for infrastructure, any of that stuff. It's a leveraged cloud service provided by AWS. It stores all the committed code into S3 bucket behind the scenes. It leverages DynamoDB for indexes into the bucket, and all the code is encrypted using the standard AWS KMS key management service. So again, it's encrypted at rest. It's even encrypted in transit, and it's has an unlimited repo size. And generally, code commit is only used for private repositories. Okay. Because you need to have a identity to access it, and this identity is managed through IAM, Identity Access Management, of the AWS cloud service. So if you want to use a public repo, go to GitHub. But if it's for a project with your customer, a project where we're leveraging proprietary source code and so forth, then this is a great use case to leverage code commit provided by AWS. Okay, so this is just a high-level intro. Let's move to the next slide where we talk about the advantages and disadvantages. So the biggest advantage, as I mentioned, is it's fully managed service provided by AWS. You don't have to worry or even think about the infrastructure, the sizing, and all that kind of stuff. It's all already there. And it's completely serverless, right? You don't have to worry about the underlying infrastructure. The cost is practically free. So for a team of 5 developers on a project, it's free. If you go 6, 7, and 8, it's just $1 per additional user. So it's pretty affordable. And again, it's tightly integrated into all the other AWS managed services. So there's hooks that you can that are built into the capability. Like if you do a commit, there's a hook that can be triggered that can cause initiation of a pipeline. We'll talk about that. So one of the disadvantages that we've encountered in our development and so forth was we did have some struggles with large files, merges, like over 70 to 100 megabytes. We're not sure if this is a standard problem across the board, but we had some minor issues with that. But anyway, because it's leveraging S3 and because of the ability of leveraging the standard encryption technology that AWS provides, and it's a standard. It adheres to Git's specifications, so you could use all the standard Git commands. It's pretty useful and great product for securing and maintaining your source code and other artifacts. All right, so that's a general summary of code commit. Any questions from anybody on this call before I move to code build? Okay, and you can also hold back your questions to the end of the presentation if you like. All right, so let's move on now to the next slide, which is code build. Okay, so code build is the framework. It's a managed service that provides the ability for a development team to build their code, right? To build packages, to really do anything you want because it relies on standard bash scripting commands. So the main concept, and we'll talk about the advantages in the next slide, but the main concept is, you want to be in control of how to deploy your package and how to build it, and you can do that through the build spec.yaml. So it's a YAML standard specification file where you can see here in the screen share on the right, you can actually put in your shell scripts to do the sequence of steps to actually build your code, and so forth. So it will compile, it'll run unit tests, it'll run integration tests. It could be part of any stage of the pipeline. We'll talk about that in the next slides. But it's a powerful tool in that sense that you have that flexibility to do what you want with the capabilities of the build spec. Let's go talk about the advantages and the disadvantages. Okay, so the advantage, again, it's a fully managed service. It's completely containerless, serverless. So you don't have to worry about having a virtual machine or an EC2 or something to spin up to actually compile and execute your code.
Yeah, sir. Sorry, but it looks like you're back at the code commit advantages slide. Is that what you mean, or did you have a different slide for code build?
Oh, how did I pop into there? That's odd. Code build. All right. Sorry, I don't know where I was clicking around.
Okay. All right, thanks.
Maybe I should be in presentation mode. Thank you so much, David. Sorry about that, guys. So, yeah. Okay, so code build advantages and disadvantages. Let's start again. So, the advantages of code build is, again, it's serverless and you don't have to provision any server. It's fully scalable, and it's free for the first 100 build minutes using the small compute instance. So it's, it can be pretty much free depending on how many times you build your stuff and throughout the month. But that falls into the disadvantage is once you go beyond that 100 on the small compute instance, you have to pay in a per minute pricing. So I gave you an example. So like if you do 5 builds on a per business day, and it's 5 minutes per build, so that will be 5 builds, and in a business day, there's 20 business days in a month. So it's 100 builds in a month, and it's 5 minutes. It's 500 minutes for the entire builds of the month. And if you use a medium instance, it's 1 cent. So it's like $5 a month for Linux. And you notice Windows is more expensive than Linux, slightly more expensive than Linux. So it will add some cost depending on how big your team is and how many builds they run. Once if you require, something bigger than the small compute instance. So if you notice, you can get to a really large build container. You can specify, I want to use something really hefty, like 15 gigs of memory and 8 CPUs to run these really build complex packages like RCase or something that requires a lot of CPU and memory. But it's a little bit, it's double the price. But relatively speaking, the price isn't too high. But unfortunately, there is a slight cost that you have to take out of your pockets. So that's code build. Any questions on code build? And we're going to get to some more interesting stuff down the road in these slides.
I have a question, Asir. This is Anil. I have
Yes.
a question. This one, when you do the code build, this is only for the deployments. It is okay, but in the current environment, in the current code build process, so like we any kind of Bamboo or Git, we trigger the code builds right after developers check in the code, and that is like a continuous integration. So that means it is an ongoing process, not a dedicated 5 minutes or 10 minutes job. Like, okay, you do 5 builds only, 6 builds only, or something, right? Is there a way we can get a dedicated version of as well from that
Yeah.
code build service from
So
AWS?
yeah. So I think you need to wait for your question till the end of the presentation because you need to understand the concept of code pipeline. And I think when we talk about code pipeline, your question might be asked in a different way. Is that fair?
Sure, no problem.
Okay. All right. So the next slides are talking about code pipeline, which is the glue that connects everything together. And I think when you hear about code pipeline, I think some things will make more sense to you. And then I ask you to repeat your question later, if it's still relevant. Okay. With that, we're going to move to code pipeline, and I'm going to hand over now the presentation to John, who's going to talk about code pipeline. John, are you on the call?
Yeah, thank you, Yasser.
Thank you.
Yeah, and I completely agree. Code pipeline, I think, is going to fill in a lot of the blanks that remain. So code pipeline is another fully managed service in AWS's suite of developer tools, DevOps tools. You can create the pipeline. You define the pipeline in code pipeline, and you can have it do whatever sequence of steps even in parallel or simultaneously that you desire, and it can be triggered by any condition that you would like. So basically anything you can imagine, anything that happens in your AWS account. The most likely would be a commit and a push to one of the code commit repos, but you can have it also trigger on random things like someone creates a file that's completely unrelated in an S3 bucket. Not sure why you would want to do that, but you can have the pipeline be triggered and as you'll see in future slides, it also integrates with many third-party services in addition to AWS's other tools that we're talking about. Next slide, please.
Yep.
So in code pipeline, you define stages. There's a minimum of 2, maximum of 50. I've never seen 50 done, but there is a cap, which might be increased someday. The first stage requires there to be at least one source action. We're going to talk about the actions in the next slide, but it's only the first stage that's using the source actions. And that's because the first stage is usually the one that is getting the source code from wherever it is stored. And then one of the stages needs to do something that's not a source action. And the stage names, the stages are all defined. You could do it through the console, or if you do it through code, it's in YAML. So like the keys cannot be duplicate. They must be unique. And there's as all services in AWS, there's limits. So an approval timeout, if you do a manual approval step, the longest it can wait for the approval to happen is 7 days. And on the right, we have a screenshot of what a code pipeline looks like that we're like using in as an example. We can go to the next slide. And now these are all the current action types that exists within Code Pipeline. So like Yasser was saying,
Sorry.
Yeah, thanks. Like Yasser was saying, with Code Build, you have a bash environment. So you could do anything, because you could do anything that you can do in a shell terminal. So you can do anything. In Code Pipeline, you only have these set of steps available to you. So like code commit, ECR, S3, Bitbucket, GitHub Enterprise. Those are your only sources that you can use. For the build stage, it currently supports Code Build and Jenkins. Test stage, there's the list, including Code Build as well. And then deploy, there's many options. We usually use CloudFormation. Then there's a manual approval and invoke. So when you do the invoke, Lambda, or step, you could do basically anything there. But the most common pattern is, if you need to do something that's not on this list, to do Code Build, but Lambda is an option as well. So you define the steps exactly as you'd like it to be laid out. And whenever there's a action that you need to take that is not directly covered by one of these events, like code commit or CloudFormation, then you go to something like Code Build or Lambda, and you define it through code, either a shell script or a Lambda function, to define exactly what you want, actions you want to perform. But the beauty of this is Code Pipeline is always available, always running, ready to be triggered based on any event. And it's not charged like as a server running per minute, like Code Build and EC2 are. And this, it can do a lot of stuff without needing to provision a server instance. So now we can move on to slide 10. And for this one, I'll hand it back to you, Yasser.
Thank you, John. Does anybody have any questions on Code Pipeline? So again, in general, Code Pipeline is the glue. It's the heart of a CI/CD pipeline, and it brings everything together to achieve your objectives for automation.
Hey, Yasser. I mean, just this is kind of a silly question. I don't see the simple email service on there, but obviously you can send out emails or other types of, like, a push notify or something based on events that happen in the pipeline.
Yes, definitely. John, you want to elaborate on that?
Yeah, I would. Yeah, I haven't done much of that, but I would expect, it would be done through simple notification service. So like simple notification service, you would have subscribed to events, just like you have a CloudWatch event that triggers your pipeline. You would have a simple notification service subscribed to a certain CloudWatch event. For when it occurs, it would trigger, and then it would have simple email service, SES, as a subscriber to it. That's my understanding of how you would do that. Yasser, another thing about the overall structure of pipeline, we might want to go back to the diagram on slide 7. It's not related to the SES, but it's related to like what you were saying about the glue that holds it together. So here you see Code Pipeline at the top, and then the services that are called from within it as we go through the different stages.
Okay, great. Thank you, John.
So David, does that make sense about SNS being used to kind of fill the gap?
Yes, thank you.
Hey, Yasser, John, I had a question. This is Kamal. We're going to be implementing something similar for Homeland Security soon. In Code Pipeline, can you call an external function or system that's not available on AWS, add it in, say, to do securitization or something else?
Could you call like a Lambda or something along those lines?
Something like
Lambda
that.
was in that list.
Yeah, right here.
And then basically from Lambda and from Code Build, you can do whatever else. Like you would have to make a little function to bridge the gap. So but that's how you would get to anything outside of this list.
Yeah, I saw that at the end. And what does it mean, invoke and approval? I mean, what does approval do? Does that mean the build is successful and then you move forward? Or I'm trying to understand that part.
Yeah, we're gonna talk about approval over here. We'll show you that the context of that, but that's basically for approving like a push to production, your deployment. Sometimes you would have to do a manual stop and then approve before you actually push the updates to production.
Okay. I'll wait for you, Yasser, to finish up the rest of it. Then I can have the other questions addressed.
Yeah, but go ahead, John.
Oh, sorry. Invoke just means invoke that function. So invoke Lambda means invoke that Lambda function. Invoke step means invoke the step function.
Yeah.
So trigger it, kick it off.
Yep.
But the approval is just in the example that we'll show in more detail in slide 11, we're doing multiple environments, and there's no point of doing multiple environments if they're going to be deployed at the same time, exactly the same. So we put a manual approval between them to be as a gate.
Yep.
Thank you.
Okay, thank you for your questions, Kamal, David. Okay, so now the use case, bringing it all together. And this is where, what was driving our efforts into this more than anything else. But in this example, it's Alfresco and Alfresco's underlying components. There are 9 that comprise the Alfresco digital business platform. So we're talking about Alfresco content server, Alfresco share, digital workspace, process services, process admin, transform router, transform engines, and so forth. So those 9 components, we're talking about 9 Docker images, 9 containers. And in our architecture, we're going to be deploying this in a serverless orchestrated environment, leveraging Elastic Container Services, ECS, Fargate. So that's the deployment pattern. And we wanted to do it with the CI/CD, automated capability. And why do we want to do that? The advantages are really clear, but I'll remind you guys, number one, everything is serverless, so we don't have to worry about any infrastructure components. There's auto scaling built in, so that you could configure the ECS orchestrated environment to scale or descale depending on low CPU utilization or high CPU utilization or memory and so forth. And there's standardization when you do it with this CI/CD pipeline. You can ensure that if there's specific version like version 16 on what's been deployed to dev, you can have that exact same version, and once it passes all the tests in dev, to move to test and then move on to production, leveraging the exact same images that were produced in the pipeline process. So that lifecycle is clearly standardized. And the process of building through CI/CD, as we described, since it's automated, it's going to be quick and behind the scenes. So I'm a developer. I make an update. I push it through. It kicks off the pipeline. I go have a coffee. I come back in 10 minutes, and it's up and running in development. I don't have to do anything. And that's the whole idea. With less work by the developers, you have higher quality. Why do you have higher quality? You have fewer failures because of automated tests, and the developers have more time to invest into the code versus worrying about, oh, does my server have enough memory? Oh, this and that, all the other issues that developers have to worry about. That's all gone now. And that comes back to the point of a shorter development cycle. And then finally, Kamal, back to your question, enhanced security. Not only do you have enhanced security through isolation of Docker containers in the orchestrated ECS cluster, each of the containers are running in their isolated container with isolated network and container communication within the VPC. But you can also do auto integration with scanning tools, like you mentioned. So you could put in the build process, you could put a call to an external scanner, pass it the location of the image on ECR, the Elastic Container Registry, and say scan this image. And this could be something the pipeline can use via Lambda, or it could be within the build, but it could scan the image for security vulnerabilities and report back to you the output of that scan. So that could be part of the enhanced security of the CI/CD pipeline. So again, we were driving this effort based on the capability to do automated deployments of the Alfresco stack. If I want to do a change to share, for example, where I want to remove some UI items, like I don't want to have the user the ability to create folders or something like that, and I want to update an AMP onto the share, like a new jar file, I want to inject it into the container. I go into code commit and I make the change. And then when I commit it and it gets approved, we'll talk about that in the next slide, the whole process that happens and gets triggered. So that's the use case. And with that, I'll move on to the next slide and I'll let John interject and go through the steps of this automated pipeline. Please, John.
Thanks, Yasser. Yeah, like Yasser was saying, the developer works locally in their local environment, probably using Docker Compose. Then when they're ready to see the change in a real environment like the dev environment, they will commit their code, commit their code to the feature branch, create a pull request. Once the pull request is approved and merged, and when it hits the branch that the pipeline is set to watch, it will trigger the code pipeline. Pipeline pulls the code from code commit, sends it to code build. Code build will run the defined steps. For example, it's unit test, checking checking the commit IDs for the images that have already been created in ECR, and then builds whichever ones are not yet in ECR. So it knows that those images need to be built. Code build will then update the CloudFormation with the latest versions for what the stack should be built with, and then pass it back to code pipeline, where code pipeline will kick off, generate change set, and then execute change set on via CloudFormation. Then we will use the manual approval step before it moves on to the next environment. So here in the diagram to the right, you'll see the steps that I laid out. Developers push to code commit triggers code pipeline calls code build updates the images in ECR, and then code pipeline works with CloudFormation to create the dev stack. Then once the dev stack is built, it can be validated through whatever means desired, and then the test environment will not be built until that manual approval in this example is approved. So then it can proceed to test. So as you can imagine, a lot of times this pipeline will be kicked off and then it will just stay in dev. The test and prod approvals will never be hit. So that's how you just keep testing something on dev. But then when a set of images is approved and good to go to test, that manual approval can be checked, and it can be defined who has permissions to approve that. And then similarly, the test to prod manual approval as well. And you do not need those steps there, but we thought this would be good to have so that the exact same CloudFormation template with the exact same versions defined will be used in dev, test, and production, so you know the exact same stack is being deployed in the future in the next environment. Any questions?
So we have a short demo. I know we're out of time though, but we do have a short demo that we recorded this morning. Do you guys want me to pull it up real quick? And we'll just run it for a minute. I'll try to fast forward the pieces. What do you think?
Please do, yes. I know some people have to leave for other meetings, but we will put the recording out there that they can watch afterwards. So yes, I think it makes sense to show the demo that you have.
Okay, let me see. I'm going to go to stream here. It's asking me to log in. Bear with me. Yeah, and basically we're just going to quickly just show you like in real time through this video. How do I just, okay. So he's going to log into the share. This is a real deployment stack, right? This is an alfresco deployment stack with those 9 components I told you about. And basically, he's going to commit a brand new amp onto share. He's going to add that amp to straight into the master branch. So it calls that trigger with a code pipeline. So he's going to commit now the change by adding that share amp to modify share. So basically, it's like a jar file. You're injecting a jar file into the web application. And basically, he's going to push it up into the master branch, which is going to trigger the pipeline. And here it is in front of us, the pipeline. And let me fast forward. So the pipeline is running. Okay. Where's my volume? All right.
So there we can see that it triggered a cloud formation. That was the change set and applied change set you were talking about, right? So cloud formation has done its thing.
Yeah, it when we push the commit to the repo, it triggers the pipeline. The pipeline triggers code build. Then code build passes back the cloud formation template, and then code pipeline kicks off cloud formation with that cloud formation template. Yasser, can you hear us?
Yeah, I can hear you.
Yeah.
Can you hear me?
In the bottom left of stream, I would recommend muting it there.
Oh.
So you could still hear us.
Oh, okay. Thank you. Can you guys hear me?
Yeah, we can hear you.
Oh,
I was
okay.
getting more nervous when I saw you mute your laptop.
Yeah, sorry guys. So I'm glad
no,
it's
it's all
John you're
good.
talking. Okay.
Yeah, it was good.
Okay, so basically, yeah, John. So we're just, it continues and continues and continues. So that's pretty much our demo. John, do you want to share some more details about this, or do you want me to move to any specific spot in the video?
No, I think
Okay.
that's it. It just, we wanted to show how we could push a commit, and then it kicks off the pipeline, and then the steps the pipeline goes through. So it generates the change set for CloudFormation, and then executes the change set.
Wonderful. Okay, we have any questions from Anil? Did we answer your question? I hope so.
He may have had to drop.
Okay.
He dropped off, yeah.
Okay, awesome. All right, so I'm gonna stop sharing my screen. I think we're done. Wonderful. Thank you everybody for your time. I hope this was meaningful to you all. We definitely encourage all of you to leverage these capabilities and reach out to us for guidance. We do like to create a model for this company, like a best practice for these type of capabilities on AWS, and that's our strategic objective for the company. So, but your support is definitely needed and lessons learned as we implement these in other projects. All right. Thank you, everybody.
Thank you, Yasser, John.
Thank you.
Right. And again, if anybody else has anything that you feel would be interesting, let me know. We can put you into a future workshop. Thanks again to Yasser and John. So I will stop recording and we will chat again. Obviously, we will not be having a workshop next week. It's a holiday in the US, so we will try to get something going the week after that. Thanks, everybody, and we will chat again soon. Bye.
Bye.